In today's video, I am showing off a multiplayer CMake project using OpenGL. It can launch multiple clients on a server, and the clients can send a message to the server to change the background color. It is also built in such a way that it can be made cross-platform very easily due to CMake. So with that out of the way, let's explain how it works. So the first thing we need to do for this project is create a CMake lists file, and I'm showing a very basic one on screen that I used, and this creates two projects and adds the main.cpp for the client and the server to each of them. Then from there, I can create this basic window using OpenGL, but this is not quite good enough as this only works on my platform. So the next thing I do is I create a root definition for all the platforms inside that main CMake file. And depending on what type of platform it is, it adds a definition. So if you're on a Windows, it'd be platform Windows, or Linux would be platform Linux. Then from there, I have a server make file instead of it just being a project built in the main CMake file. And I also have a client CMake file. And this one does the same thing, except it just works for the client, and it includes all the libraries such as OpenGL that we only need on the client side. Now with all those changes, I could redo the client's main code, and as you see there, I added this little if dev Mac platform. So if we're on the platform Mac, it'll add this special code, which is the very beginning of how we can make this cross-platform multiplayer app. So the next thing I did was create this OpenGL scene right here with a bunch of cubes that you can fly around, and it's 3D. And this uses a renderer class, which you wouldn't have to. However, if you wanted to port this to, let's say, mobile, which uses OpenGL ES, uses a different version of OpenGL, this is a great way to abstract it so that all the logic can remain the same, but you can actually change the code. So the way we do this is that the main.cpp file for the client only interfaces with this renderer class and handles none of the drawing itself. And in renderer.h, we set up all the definitions for the renderer class, but none of the implementation. And then we include a type of header file based on the platform. So for Windows, Linux, and Mac, I use the comp renderer. And I also have shader.h defined in the same way as well, so that all the shader logic can be applied to both platforms. Then in comp renderer, it's very similar to what we had before, where it's all the OpenGL code and all the rendering stuff. However, this time, if I wanted to port this to mobile, I could rewrite this code in OpenGL ES, and it would work on mobile because it could hook up to the renderer class, which would be called by the main file. And finally, what I do is I add all the client code that connects with the server, and then I add all the server code so that now the client and server can talk. And what I made them do is the client can send a message to the server to change the background color, and then the server will send that to all the clients. So as you can see here, all of the clients have their backgrounds synced up. And the way we do that is first in our renderer code, in our comp renderer, we have this input right here that's if the user types R, G, or B, it will send a message to the client, which is still on the client side, to send the server a message to change the background color. Then the client's code, what it does is when the client is created, it will connect to the server, and then we have this function here called send message, which will send a message, and the one we use is send color. And then in our server code, we have it set up so that when it receives a message from send color, it will send a message back to all clients of the type server card, and this will send a packet that tells all the clients to change their background color. Then we have client update, which is inside the client's code and not part of the renderer, and this modifies board. Now board is this small header file we have with a bunch of global variables, and for right now all it has is an atomic for the red part of the sky color, the blue part, and the green part. And then in our renderer, we can use that by simply, whenever we draw the scene, we just load the values from those three. And if you want to learn more about this multiplayer setup, you should check out this video here, where I use it in a multiplayer card game that I've been working on. And until next time, see ya.